Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, or DTC P0105, indicates a malfunction of the manifold absolute pressure map sensor in the Honda Fit models from 2015 to 2020. The map sensor plays a crucial role in monitoring the engine's air intake pressure, which is vital for the Engine Control Module, ECM, to calculate the optimal air-fuel mixture for combustion. In this instance, the sensor's readings are reported to be out of the normal range, indicating a possible fault. This issue can arise due to the map sensor itself, wiring issues, or even the Engine Control Module, ECM. Upon detecting DTC P0105, it is essential to follow a structured troubleshooting process to confirm the fault and identify the underlying issue, ensuring that corrective measures can be implemented to restore proper engine function. The map sensor is responsible for measuring the manifold pressure of the engine and providing this data to the Engine Control Module, ECM, for optimal engine performance. It usually is located on or near the intake manifold. When the map sensor fails or gives erroneous readings, it can result in poor engine performance and emissions issues. The typical operation involves monitoring the intake manifold's absolute pressure and sending voltage signals back to the ECM. Normal sensor voltage values range between 0.5 volts to 4.5 volts, and the failure is indicated when the map sensor readings fall below 0.32 volts or rise above 3.25 volts. These thresholds are critical for diagnosing and fixing the error effectively, as they pinpoint the nature of the malfunction within the sensor or circuitry. Several factors can lead to the activation of DTC P0105. The most common culprit is a faulty map sensor itself, which might fail due to wear or internal damage affecting its ability to send accurate readings. Additionally, wiring issues can also trigger this DTC. For instance, a short or open circuit in the wires connecting the map sensor to the engine control module can cause erroneous signals. Problems with connectors, such as corrosion or looseness, may also lead to intermittent connections, resulting in voltage discrepancies. Lastly, if the ECM, which processes data from the sensor, itself is malfunctioning, it may misinterpret normal signals or completely lose contact with the sensor, further complicating diagnostics. Vehicles experiencing DTC P0105 often exhibit several noticeable symptoms. The most common initial indication is the illumination of the check engine light on the dashboard, signaling a malfunction detected by the vehicle's onboard diagnostics. Drivers may also notice performance issues, such as rough idling or sluggish acceleration, due to incorrect air-fuel mixtures being supplied. These symptoms often result from inaccurate map sensor readings, leading to poor engine performance. Additionally, increased emissions might occur as the ECM struggles to adjust the mixture for optimal combustion. Understanding these symptoms can guide technicians in identifying and rectifying the underlying problem effectively. The first troubleshooting step involves problem verification by setting the vehicle to on mode, allowing the technician to access the Honda Diagnostic System, HDS, to evaluate the map sensor's signal. Begin by checking the map sensor's current voltage value against its specified threshold of less than 0.32 volts. If the current reading matches this threshold, it confirms that the fault has been effectively duplicated, allowing you to proceed to Step 3. However, if it does not match, you should move on to Step 2 to further investigate possible issues with the system, such as intermittent failures or wiring problems. This step ensures that any subsequent diagnosis is based on accurate initial readings. In the second troubleshooting step, again utilize the HDS to monitor the map sensor's voltage. This time, checking to see if the reading exceeds 3.25 volts. If it does, it confirms a fault condition has been duplicated, prompting you to move to Step 7. Should the readings not match the threshold of over 3.25 volts, it indicates that the failure may be intermittent. This situation requires attention to wiring integrity. The technician must inspect for any poor connections or loose terminals at the map sensor and the engine control module, ECM. If an onboard snapshot of the DTC has been recorded, it is essential to attempt to replicate the exact conditions that triggered this fault for a more accurate diagnosis. To proceed with diagnosing possible failures, the third step requires turning off the vehicle completely. After this, disconnect the map sensor's 3P connector to isolate the sensor from the system. With the sensor detached, switch the ignition to on mode again, and using the HDS, check the voltage output from the map sensor. If the measurement falls below 0.32 volts, the next step is to go to Step 6, indicating that further issues may lie within the map sensor itself or the components connected to it. However, if the value is above this threshold, it directs the technician to Step 4 for an accurate assessment of the wiring and connections involved. In the fourth troubleshooting step, the technician is instructed to measure the voltage between two specific test points on the MAP sensor's 3P connector while in the vehicle's on mode. The objective is to validate if the voltage reading is approximately 5.0 volts. If the reading is confirmed to be within that range, it necessitates replacing the MAP sensor itself due to its inability to provide accurate data. Conversely, if the voltage is not around 5.0 volts, this indicates a different failure within the system that requires checking for possible issues in the wiring or connections. This step is crucial as it directly determines if the sensor is faulty and needs to be replaced or if further diagnostics must be conducted. A fifth step involves checking for continuity of the VCC1 wire between the map sensor and the engine control module, ECM, to ensure that there are no breaks or faults in the wiring. Before conducting this, the vehicle must be turned off, and the SCS line needs to be jumped with the HDS for at least 1 minute. With the PCM disconnected, measure continuity between specified test points, the map sensor, and the corresponding PCM terminal. If continuity is present, it suggests the VCC1 wire is functioning correctly. If continuity is absent, it indicates there is an open circuit in the wiring which needs repair. This step is essential to confirm that the wiring can adequately transmit signals between the map sensor and the ECM. Moving forward to the sixth troubleshooting step, after ensuring that the vehicle is off and the SCS line is jumped with the HDS, the technician must check between specified test points for continuity between the map sensor's PB line and the body ground. This step targets potential short circuits that may be affecting the signal. If continuity is found, it indicates a short in the PB wire, and corrective measures need to be implemented to repair that wire. Conversely, if continuity is not present, this suggests the PB wire is intact, and thus the technician should refer to any authorized service documentation relative to the troubleshooting process. This step emphasizes validating the integrity of the wires, ensuring that all connections can perform as expected. In the seventh troubleshooting step, the technician is to reconnect the map sensor with the 3P connector and connect terminals A and B directly utilizing a jumper wire. By doing so, you can simulate conditions to test whether the sensor can reach the required voltage when the vehicle is switched to on mode. The objective here is to verify if the map sensor's output exceeds the threshold of 3.25 volts. If successful, this validates that the sensor should be replaced as it's not functioning correctly. If the voltage does not exceed this threshold, the next steps need to involve testing other components within the system to isolate the fault accurately and correctly address it. For the 8th step, begin by removing the jumper wire used in the previous test to return the map sensor to standard operation conditions. Then, turn the vehicle on again and measure the voltage between 2 test points on the 3P connector. In this step, you're checking to see if there is approximately 5.0 volts. If the voltage reading confirms this value is present, then the SG1 wire is functioning correctly. And the technician should refer to any service documentation related to the DTCs or symptoms. However, if the voltage is absent, the follow-up action would involve checking the wiring for faults, since this indicates a failure in the connection between the PCM and the map sensor. The 9th step focuses on identifying any open issues, specifically in the SG1 line. The technician must perform this check with the vehicle in off mode and ensure the SCS line is jumped. With the map sensor disconnected alongside the PCM, it's crucial to measure continuity between the specified test points. If continuity is present, this indicates the SG1 wire is intact and functioning effectively, directing the technician back to the service documentation for further troubleshooting if needed. However, if no continuity is found, this signals that an open exists in the wire leading from the PCM to the map sensor, requiring immediate repair. This is essential to restore proper signaling in the electronic system. The final troubleshooting step entails verifying the integrity of the PB line through an open wire check. This procedure follows the same protocol as previously described. The vehicle must be off and the SCS line jumped with HDS for some time. Evaluate continuity between the map sensor's PB terminal and the corresponding PCM terminal. A positive continuity check suggests the PB wire is intact, allowing you to return to the service documentation to reassess the symptoms or consider substituting the PCM if the P0105 persists. Conversely, if continuity is lacking, this means there is an open line that needs to be repaired. Proper rectification ensures that voltage signals can be communicated effectively from the map sensor to the PCM. Once repairs have been completed for the DTC P0105, it's imperative to conduct a thorough test drive of the vehicle to ensure that everything functions properly. This drive allows for real-time evaluation of engine performance and checks for any potential reoccurrences of the DTC. After the drive, utilizing the HDS once more to confirm that no new DTCs have been recorded is essential. Final checks should revisit all repaired connections, ensuring they are secure and free from contamination or corrosion. This process validates that the initial issue has been completely resolved, enhancing overall engine performance and reliability. Preventive maintenance is crucial in avoiding future occurrences of DTC P0105. Regular inspections of wiring and connectors associated with the map sensor can help identify wear or any developing issues before they cause significant problems. Cleaning both sensors and connectors ensures that no dirt or corrosion obstructs signal transmission, which is vital for accurate readings. Additionally, routinely checking for corrosion at connection points helps to maintain strong electrical contacts. Adopting these practices can significantly reduce the likelihood of sensor failures, maintaining optimal engine performance and prolonging the lifespan of vehicle components. In summary, DTC P0105 highlights an issue with the map sensor, a vital component for maintaining proper engine function in the Honda Fit models from 2015 to 2020. The systematic troubleshooting steps outlined guide technicians in accurately diagnosing the root cause of the issue, whether it be the sensor itself, wiring, or potentially the PCM. By following through with each troubleshooting step, technicians can accurately identify the fault and take corrective action to resolve the DTC. Additionally, regular maintenance practices are essential to prevent future occurrences of this fault. Understanding these elements equips vehicle owners and technicians alike with the necessary knowledge to maintain the performance of their Honda Fit. Please like and subscribe to the channel. See you next time!